Now let us go ahead and set up Hive and Impala on our cluster. So here I'm using Cloudera Manager, and as part of Cloudera Manager, I'm expanding this and clicking on Add Service. First we'll set up Hive quickly, and then we'll actually get into setting up of Impala. So when it comes to Hive, you need to choose this and then click on Continue. Hive doesn't have any slave components because it uses HDFS for file system and MapReduce for processing, and hence we don't need to configure any slave components. However, when it comes to masters, those masters are primarily to support the metadata which is required to run our Hive queries such as create table, load, select, etc. So in this case, as we have both Spark as well as MapReduce, we will be choosing this. If there is no Spark, we should be choosing this. Okay, so let's choose this one where it will try to configure itself to use both HDFS and Spark, and then click on continue. So when it comes to gateway, we'll be configuring all the servers as gateways. In case if you want to run the queries, we can run the queries from any node. And also when we actually set up Uzi later, if we have to configure Hive queries as part of Uzi scheduler or workflows, we have to configure each and every node as gateway. For that reason, we are leaving as is. All the servers in our cluster are considered as gateway here. Then when it comes to Hive Metastore server, as per our planning, we are supposed to use Big Data Server 4. And then even for the Hive server, we will be using Big Data Server 4, not Big Data Server 1. You can have Hive server running on multiple nodes for high availability and fault tolerance purposes, but configuring on one host is good enough. For now, let us ignore Web HCAT server. It is primarily to provide APIs to access metadata that is being stored in Hive. So programmatically, if you want to check what is the structure of the table and all, it uses this web hcatlog server. Hcat means hcatlog. Then you can click on continue. Now you are supposed to configure the database because Hive uses a relational database to store metadata of your tables. So when we actually run create table command, whatever name you give to table, whatever columns you define, whatever data types you specify to those columns, the location of the data on which you are trying to create the table, all these constitute metadata. And Hive actually stored that metadata in a traditional RDBMS. And in our case, we have actually set up MySQL server on Big Data Server 1, and we have actually created databases such as Hive, Hive, Uzi, etc. Now we have to use one of those databases which we have already configured. For that purpose, we have to change the database host to Big Data Server 1. Database type is MySQL, database name is Hive, username is Hive, and then ITversity. MySQL server was set up as part of installing core components before adding any service onto the cluster, even before setting up of Cloudera Manager. First, we actually set up the databases and then we proceeded further. That being said, you can actually say test connection. If it fail here, then you have to go to Big Data Server 4 and install MySQL connector Java on that. Now you see JDBC driver cannot be found. Unable to find the JDBC database jar on host Big Data Server 4 because we only set up Hive on first server, which is nothing but Big Data Server 1, and then we installed the client, which is nothing but a jar file, to use the database with respect to any JDBC based applications on Big Data Server 1 alone. We haven't installed on any other node. However, here, as our Hive server is running on Big Data Server 4 and our database is running on Big Data Server 1, we have to have the JDBC driver installed on Big Data Server 4. For that, you need to open the terminal and then log into Big Data Server 1. Once you are on Big Data Server 1, you have to connect to Big Data Server 4. So this will actually establish connection to Big Data Server 4. Now you are on Big Data Server 4. Sudo yum-y install MySQL connector Java and hit enter. It will actually download the MySQL connector java.jar file and all its dependencies. You can find that file in this location once the setup is done. It is nothing but user share java MySQL connector java.jar. Okay. So it will automatically use this once we set it up. If we try to test connection, you can hit on continue now. You can review these properties. We will leave as is. So this is the HDFS location in which all your tables, databases will be typically stored. You can also create something called external tables which might not use this location, but standard managed tables and databases will be created as directories under this base location. There will be multiple directories and subdirectories in which our Hive tables will be created, or the data associated with our Hive table will be stored. That being said, you can click on continue. It will take a while to deploy the service on our cluster, and start the server components of Hive, which are nothing but Hive Metastore and Hive Server. Now Hive service is configured on our cluster and also started. We can hit on continue and then finish. Similarly, now we can actually click on this and then add service, and then we can actually add Impala as well. You cannot add more than one service at a time once you have a service in a cluster. Only at the beginning you should be able to add multiple services in one shot using different categories which provided as option to you. But we started as custom services, and then we set up Zookeeper, then HDFS, then other services as we proceed further. That being said, when it comes to Impala, there are both master components as well as slave or worker components. When it comes to master, I want to set up Impala state store on Big Data Server 3 as per our capacity planning. It is similar to name node or resource manager. It will actually keep on monitoring the slave components of Impala, which are nothing but Impala daemons, which are configured to run on the same host where our data nodes are. So even though Impala uses a different approach to process the data, still the file system is HDFS itself. That's why it automatically chose those servers where data nodes are running. This is the typical way of setting up the cluster. That being said, we have another master component which is nothing but Impala catalog server. It is similar to Hive Metastore. It will facilitate the Impala queries to use Hive Metastore. So in this case, we want to configure Impala catalog server on Big Data Server 4 and click on OK. And then you can hit on continue. Without Hive Metastore, if you try to set up Impala service, then it will not work. First, you need to set up Hive, at least Hive Metastore, if not all the components of Hive, then only you should go ahead and set up Impala. You can just review these things. So these are the scratch directories which will be used as part of the processing. So data will be temporarily stored, and it has picked up the location of /data1 /impala/impala-d. /data1 is nothing but directory pointing to the additional storage which we have configured on each of the node in the cluster. If you want to add more, you can actually click on plus and add more. However, it will automatically identify all those additional directories which are pointing to that additional storage. Then you can click on continue, and it will take care of setting up of Impala as a service on our cluster. Now it is started as well. Just click on continue and finish. You have the database engines such as Hive and Impala configured on our cluster. Let us refresh this page to see everything with respect to Hive and Impala are started without any issues. Impala service did not come up automatically for us, so we have to click on start here. And also you can see there is a orange icon which you need to click and restart this tail service. It is actually updating one of the properties with respect to HDFS when we set up Impala. For that reason, it is asking us to restart. So I'm not going to use rolling restart. I'll be restarting everything in one shot. Okay, I think I will leave as is. We will be performing rolling restart. We have to restart only HDFS because only HDFS related property is changed, others are not changed. And then click on restart now. It will take care of restarting HDFS data nodes. As only HDFS data nodes are restarted, no service will be impacted as of now. Now restart of HDFS is also done. We can click on finish and go here. Everything looks good. Now let us go ahead and validate whether Hive and Impala are set up properly or not by running some queries before we get into the details with respect to these two services that are added to the cluster.